those are 50% of the answers from yesterday's quiz. Take a picture or a screenshot. If you didn't complete it yet, you can submit, but submit the whole thing. Submit this 50% and try to figure out the other 50% answers, the other half of the quiz. We started this new topic, polynomials, on Monday. Monday we're talking about definition of polynomial. Polynomial is a combination of two words, polynomials, that mean many terms. So it's when you have a bunch of terms together in an expression, then this is a polynomial. Yesterday we worked on these properties of exponents that we can apply, we can use to simplify expressions, and at the end of the day we will be able to simplify polynomials using these properties of exponents. The first property, multiplication of like bases. So let me multiplication of like bases. Remember, we have to add the exponents. Next property, division of like bases. And this one we will subtract. We're going to subtract exponents. Next property, power rule. And this property here, check this out. To find out the result, we need to multiply the exponents. And power of a product and power of a quotient is a property that we can distribute the exponent among the factors. So this is, it looks like distributive property, but it's you distribute the exponent among the numerator, denominator, or factors in the multiplication. Yesterday we worked on a bunch of questions. We practiced these properties, how to apply, how to simplify, how to work with these properties. And today we will see a slightly different topic, a new topic, and we're kind of going to use these properties as well. But it's going to be a new topic on scientific notation. You can read this definition. You can check here what scientific notation is, but I think it's better to understand when we work, when we see the examples. Scientific notation is something used to represent very large numbers or very tiny, small numbers. Okay? Examples we have here: the distance between the sun and the earth, which is going to be 93 million miles. This is a large number, right? 93 million miles. We can represent in a short way. It's easier to work with this. It's equals to 9.3 times 10 exponent 7. And this is the same number represented using scientific notation. Another number, but now it's a teeny tiny, very small number, the mass of an electron. You know, an electron is one of the bits, the parts of the atom, right? So it's really tiny, really small. And the mass of an electron is 0.0000, so many zeros here, so many zeros, 911. Okay. When we work on this kind of amount with this kind of number, it's easy to miss one zero or to type one more zero and mess up with your calculations, okay? And that's another reason we work with scientific notation. Check this out here. The same number representing scientific notation is a short one, 9.11 times 10 exponent negative 31. And there's less of a chance of missing one zero or adding one zero, right? It's less probable, it's less chances to make mistakes. So there's a scientific notation. Let's see a few examples, apply scientific notation, and then we will work on several other examples on the quiz. Okay? Let's check this out. This is the first one, letter A. There's a story here that during a recent economic crisis, the U.S. government, yada yada yada, and you don't need to kind of get involved in the whole context, okay? Wait, why for the first example there is 7 places? So there will be only zeros. What do you mean 7 places? You will. Why for the first example there is 7 places? Okay, let's check. Let me see here. Wait a minute. Let me work the example. Then you ask again the question. Okay. During the recent economic crisis, don't focus on the whole story. Just let's focus on the numbers. And we have one number here, 750. I think this is billion, right? $750 billion. It's going to be divided for 300 million people. This is a division. It's just a division with very large numbers. Okay, $750 billion divided by 300 million people, right? If you go back up to the first example, it counts all the zeros, but also the 3. Go back. Okay, let's go back. Let's go back. Oh, okay. Yes. You get when you're representing the using scientific notation, you just have to identify the first digit that's significant. The first significant digit here is the 9, and the first significant digit here on the other example is, just by coincidence, is this 9 here. We will get this first digit, 9, and we're going to move the dot, see the dot, right before this 9, before the 9. So we're going to move 1, 2, 3, 4, 5, 6, 7 places. And this is going to be 9.3 times 10 exponent 7. I understand what you mean. We're not going to represent like this, 93, no, times 10 exponent 6. No, we're not going to represent like this. We're always going to represent this first number is going to be less than 10. Always less than 10. So it's something between 0 point something all the way up to 9.999 something. Okay? Yeah. Let's check here. We're going to do the same thing here. The first digit that's significant on $750 billion is 7, right? So this is the first digit, 7. We're going to move the point or the dot all the way here before the 7. 1, 2, 3, 4, 5, 6, 7, 8. So this is equals 7.5 times 10 exponent 8. And let's do the same thing. The other number that we have is 300 million. And we're going to do the same thing. Identify let me get this. The first digit is 3. We're going to move the dot, the point, right before, right after 3. 1, 2, 3, 4, 5, 6, 7, 8. Oops, there's something. Oh, I forgot a few zeros here. I forgot a few zeros. We have, let me just fix this. Sorry, I forgot a few zeros here on the top. It's billion, not million. Billion. 1, 2, 3. And this is equals to 7.5 times 10 exponents 11. Yes, 11. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Billion, yes, you missed 3. Yes, thank you, Ariel. And the next one is 3.0 times 10 exponents 8. And you can see the reason we need scientific notation. It's useful because it's really hard to work with this many zeros, and we can miss, you can forget zeros, you can put zeros, we can add extra zeros and then mess up all our calculations. What we need to do here is to divide. We want to see how much money each people is going to have. So we will divide this 7.5 times 10 exponent 11 by 3.0 times 10 exponent 8. This is what the question is asking. And when we do this using scientific notation, it's kind of easier because we can split. You can do this fraction here multiplied by this fraction. Let's split these two fractions apart. So we have 7.5 divided by 3 is 2.5 times, and 10 exponent 11 divided by 10 exponent 8 is 10. Remember the property that we worked yesterday? We subtract the exponents. So this is equals 2.5 times 10 exponent 11 minus 8, 3. That's it. This is how we will apply scientific notation. And this example here is for large numbers. We can also apply it to solve problems with very small numbers. Let me get the whole thing. Yeah. And interesting. Yes, it's interesting. And there's another thing that is even more interesting. You can also use your calculator. And I don't know who came up. Someone very clever, for sure. Very bright. Yeah. I don't know who exactly came up with this idea. But it's a good idea, right? It makes things simpler. And I'm going to show another interesting thing. You can use your calculator to work with scientific notation, to check your answers. But let's move on. If there's any question, any specific question, let me know now. If not, let's move to the bell work. And after that, to the quiz. Okay? Any questions? No questions? Any complaints? Any comments? There's too much stuff going on. Yes, Kalia. Too much stuff going on. But don't worry, we're gonna practice this on the quiz. The best thing, I'm gonna show you how to use a calculator to check your answers, and you will see it's not complicated. This is actually something that makes things easier, make your life a bit easier. Going back here to the bell work. Right now, let's answer. The Christmas is over, but this Mr. Pascal has the house still decorated. But the ornament right at the bottom of the tree is missing. Can you figure out what's the number? Can you find out a sense, how to make sense of this sequence? What do you think? Let's check the right answer now. No more messages. Let me clean this up. It might be 50, it might be 60 or 70. Let's, well, as I told you, the key, and you will, 60. Okay, one more, 60. The key to answer this question here is on the name of the guy. This Mr. Pascal. It's not an unusual name, and here we was talking here about mathematicians, right? And Archimedes, and Descartes, and Pascal is also a mathematician, very famous mathematician. If you type on Google the Pascal tree, you find this, Pascal's triangle. And this is how it looks like. See, the way this this triangle, this tree is built, is like that. Let me show here. We get the two numbers on the top. We add them up, and we're gonna find the number on the bottom. So 1 plus 1 is 2. 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5, 15, and on like that. And this tree actually have no end, it goes on and on forever. Let me see more here. 15 plus 6, 21, and the one that we're looking for this on the bottom, this. So we have to add 35 plus 35, which is going to be 70. 70 is the right answer. So 70 is going to be the right answer. Oops, new messages. Yes. Yeah, and have lots of applications. This the Pascal tree is something that have lots of applications. Later, maybe on this course we will be able to use or apply, but especially in quadratic or perfect polynomials. We will see something later about Pascal tree, but this is at least have one application here, which is to answer our bell work. And the bell work is going to be 70. 70, and the winner, let me see the winner here, is Johnny L. The first one to answer 70. Thank you, Johnny L, Jacob, Kalia, Chris DL, Anjali, Keon also answered 70. Maddie also 70. Thank you, Keon, Maddie, and Ewell. Let's move. Let's go now to our quiz. Let me try to just change something here. Okay, better. This is our quiz. The question, we have two parts. The first part, write the number using scientific notation. The second part here, perform the indicated operations and write the answer in scientific notation. Let me see here letter A as an example. So represent this using scientific notation. 3 million DVDs. So we have 3 million. And first thing you have to do, identify the points. The dot is here, 0.0, right? We're gonna move the dot all the way to the first digit, the first significant digit, which is 3. So move 1, 2, 3, 4, 5, 6. 6 places. And the answer is gonna be 3.0. Don't forget to write down 0.0 times 10 exponent 6. When you are writing this on forms, just don't forget to represent the exponents. check this out. Let me do again. Let me work this again here. Just 3. Type 3.0. Don't forget 3.0. Type the multiplication sign times 10. And don't forget this, the exponent, okay? Type exponent 6. This is how you will answer on forms, okay? Don't forget the exponents. The bell work is 70, Kalia. 70. 70. All right. I will check real quick the attendance, and after that we can work together. You can ask questions. You can ask to work here on the screen on any of the questions, on all the questions. We actually can complete the whole quiz if you want.
All right, okay. This is the 4th period. Oops. Okay.
Have a good day, Mandy. Have a great day, Christiel. Bye-bye. Thank you, Will.
Bye, have a great day.